What's going on, Science Tins? Today we're going to be doing our first topic from our new unit, which is physics. And the very first thing that we have to kind of talk about is some math skills. And so we got to start talking about scientific notation. And tomorrow we're going to talk about significant digits, and we'll do some other math stuff. But today's focus is on scientific notation. Now, you might not have any idea what scientific notation is, but scientific notation is a way of writing really big numbers and really small numbers as just a normal number times a power of 10. For example, I could write 6.5 million. There's a normal way to write that, right? 6.5 million is 6,500,000. And I could rewrite this. As 6.5, right? If it's 6.5 million, that's like saying 6.5 times 10 to the power of 6, because 10 to the power of 6 is a million. So that's like saying this is how many millions we have, 6.5 millions, times, and well, this is just a million. So it's one way of writing really big numbers as just kind of a regular number times a power of 10. So let's go through this, a little bit, and we'll see where we can get to today. So sometimes numbers are so large or so small they become very inconvenient to write out. For example, these two are pretty good examples here. We got the mass of the Earth and a mass of a proton. Let's talk about the mass of the Earth. If you don't know, that's the planet you live on. And I've already kind of looked up the mass of the Earth. The mass of the Earth is, and bear with me, 59720000000000000000000. Let's see. Perfect. Kilograms. That's how big the Earth is. And just by way of an example, I just want to compare that to the mass of, me. The mass of Mr. Walton is about 70 kilograms. Sorry, my pen's not working very well. 70 kilograms. And so, yeah, obviously that's a really big number. It's a really inconvenient number as well because it's so massive. Why? You don't want to have to write all these zeros. So we're going to go through a process to be able to write that as a regular number. So for example, 5.972 times 10 to the power something, not 6, because it's not millions anymore. Let's talk about the mass of a proton. I don't know if you know this. You should, because we've already talked about chemistry. But a proton is one of our subatomic particles. So it's tinier than an atom. And atoms are already pretty tiny. So we're going to go ahead and write out the mass of a proton. 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 That's a tiny number as well. If you want to write that out multiple times in a row, then that's going to be a real pain in the buttocks to be able to write in as a normal way. So again, we're going to try and figure out a way to write that in scientific notation where it's just a regular number times 10 to the power of something. So this will be 1.6 or 7 times 10 to the power of something. So as we can see, it'd be pretty annoying to write out these numbers multiple times. Fortunately, we can use scientific notation in a more convenient way. Scientific notation is a way of writing a number multiplied by a power of 10. I knew this was coming up later on, right? $6.5 million can be written as 6.5 times 10 to the power 6. Basically, what this means is we're going from $6.5 million, right? The decimal is right at the end here. that's where the decimal is, right? This is 6,500,000, no 10,000, no 1,000, no 100, no tens, and no ones. The decimal's always after that ones value. What we're going to do is we're going to use powers of 10, and we're going to just shift the decimal place over. So remember, this is like saying 6.5 times a million. 6.5 million is a lot like saying 6.5 times 1 million. Well, 1 million can be written as 10 to the power 6 because there's 6 zeros in here. My pen's not working very well, but trust me, there's 6 zeros. So that's how we can do that. We can convert between normal numbers and scientific notation numbers just by sliding the decimal place until it rests behind the first non-zero number that you see. So let's try and do a couple of these. Convert the following numbers to scientific notation. We got 537,000 here. So we're going to write this as if the decimal is right there. We're going to move the decimal from here. It's after that last zero, and we're going to move it over until it becomes 5.37 times 10 to the something. Now, the way you think about this is this number right now, 537,000. It's bigger than 1, right? 537,000 is bigger than 1. So that's times 10 to the positive exponent. How many? We're going to move it 1, 2, 3, 4, 5. We had to move that decimal place 5 times, so it becomes 5.37 times 10 to the 5. So that's how we would write this number in scientific notation. Here, this new number, 0.0000856, that number is less than 1. It's smaller than 1. So we're going to write this as times 10 to the negative exponent, indicating that the value is smaller than 1. So we're going to move the decimal all the way over until it rests between the 8 and the 5. It has to go just after the very first non-zero digit. So we're going to move it 1, 2, 3, 4, 5. So it's going to be 8.56 times 10 to the negative 5. Here, this value, 0.0025, it's less than 1, so it's going to be times 10 to the negative something. 1, 2, 3. So it's going to be 2.5 times 10 to the negative 3. Hopefully this makes sense. Our values with a positive exponent are always greater than 1. Our values with a negative exponent are always less than 1. And hopefully you kind of remember that from Math 9 or Math 10 Common, right? Negative 10 to the negative something is like dividing by 10. 10 to the positive something is like multiplying by 10. Here we go. This value, the decimal is here, right? It's there right now, and we're going to move it to the left, and we're going to see how many times we have to move it to the left. So 2.39 times 10 to the positive, 1, 2, 3, 4, 5, 6, 7. 7. 2.39 times 10 to the positive 7. Let's kind of go another way for this. Let's convert the following scientific notations into normal notation. So this is 9.2 times 10 to the negative 4. Remember, this number is going to be smaller than 1. So it's going to be 0.0 something. So I would move this decimal 4 times, and I'm going to move it 4 times to whatever direction makes it less than 1 in the end. So I'm going to write 9.2, and I'm going to see which direction do I have to move it. If I move the decimal to the right 1, 2, 3, 4 times, it becomes 92,000. Well, that's not what I want. We don't want a big number. We want a small number because the value is 0. Or the value is less than 1, sorry. So let's move that digit 4 times to the left instead. 1, 2, 3, 4. So we'll go 0, 0.00092. So what that is, 0.00092. And yeah, that makes sense. This value is less than 1, is to the -4. And if I were to convert this back into scientific notation, 1, 2, 3, 4, yeah, this would be 9.2 times 10 to the -4. Let's convert 6.94 times 10 to the +4. So remember, our exponent here is how many times we're moving the decimal. And then the 6.94, we're just going to move that decimal wherever it is to whichever side makes it either greater than 1 or less than 1. So let's try this. 6.94, and we're going to move the decimal either to the left or to the right. Let's think about this. If I move it to the left, that's making the number smaller. It'd be 0.0 something 694. That's not good. We don't want a number smaller than 1. We want it to be greater than 1. So let's move it to the right. 1, 2, 3, 4. And I'll rewrite the decimal there. And I'll fill in the rest with zeros. So 69,400. And the decimal's there. Good. Yeah, this number is pretty big. It's pretty large because it's got a positive exponent. Hopefully that makes sense. Okay, again, greater, right? It's got to be bigger because it's a positive exponent. So I'm going to move the decimal 7 times to whichever side makes it bigger. 1, 2, 3, 4, 5, 6, 7. So 1.8, sorry. That'll be 18203,000. So we have 18,203,000. That's what our number is. 6.81 times 10 to the -2. 6.81 times 10 to the -2. So 0.0681. 0.0681. Hopefully that makes a little bit of sense. What I want you to do now is I want you to convert this number and this number into scientific notation. So for example, the mass of the Earth, this number is huge, it's massive, so it's going to be times 10 to the positive something. The mass of a proton, this number is tiny, 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 so it's going to be times 10 to the negative something. And I just want you to practice that, that's all, okay? So convert the mass of an electron and the mass of the Earth into scientific notation. Check the notes, check the key for the notes, or the key of the notes for the answers. And then what I want you to do is I want you to try this next it's just like a little puzzle. It's going to have a really, really dumb joke at the end, but hopefully you're okay with that. So the instructions say, express the number in each statement below in scientific notation. Select the answer from the 2 choices. Write the letter of the correct choice in the box at the bottom of the page. So we'll do the first one. The mean or average distance from the surface of the Earth to the surface of the moon is 376,000 kilometers. Now that's a big number, right? We got to figure out how big is it. The decimal's here. This is a comma. So I'm going to move the decimal all the way until it's behind the first digit. So 1, 2, 3, 4, 5. 3.76 times 10 to the 5. So I'm going to take E, and I'll write E wherever I see a 1. So that was question 1. And wherever I see a 1, I'm going to write an E. And then you just go through and it'll have a dumb joke, and that's totally fine. It's not that big of a deal. So that's what I want you to do. I want you to work on this worksheet, and then we're going to continue to use scientific notation for the rest of the semester, basically. Let me know if you have any questions. Have a good day.